The Proterozoic Eon is the next eon of geologic time. Proteros in Greek means early, and zoe means life. So this is where we have abundant examples of early life living on Earth. Now, for the time being, the Proterozoic Eon is defined as beginning at 2.50 billion years ago. This is a fairly arbitrary beginning until more evidence can be found to point to a good place to divide the Archean from the Proterozoic. But during the Proterozoic Eon, a lot of major changes happened to Earth, leading us to the eventual modern Earth we see today. For example, in the start of the Proterozoic from 2.4 to 2.0 billion years ago was the Great Oxygenation Event. At this point in time, photosynthesis evolved. Organisms such as cyanobacteria initially took in sunlight, took in carbon dioxide to create sugars that fed them. Eventually, photosynthesis has evolved in other ways. Today, plants photosynthesize, but at this point, there were no plants. The byproduct of creating these sugars in the cyanobacteria and plants as well is the respiration of oxygen gas. So the arrival of photosynthesis led to a dramatic increase in free oxygen gas in the atmosphere. Oxygen gas in the atmosphere became in equilibrium with oxygen in the water. It dissolved a little bit in the water, which reacted with the iron in the water. Prior to this time, iron was soluble. However, iron oxides formed because oxygen is very reactive, and iron oxides are insoluble, and so a lot of iron oxides were precipitated at this time. These are known as the banded iron formations, where we have rocks of alternating bands of red hematite and gray chert. These banded iron formations are the major source for iron ores worldwide. Major changes on the topic of life also occurred during the Proterozoic Eon. Initially, life began as prokaryotes, or primitive single-cell organisms. These include things like bacteria, archaea, and even cyanobacteria. Some of the first fossils from this time frame are known as stromatolites, which are algal mats that form into mounds, and as these algal mats grew in a mound shape, they captured sediment, stuck to them, and we can find sediment well beyond the angle of repose. Today, stromatolites primarily only exist in Shark Bay, Australia, as you can see on this top picture. But in the rock record, in the bottom picture, we have a lot of stromatolites that are preserved. Sediments well beyond the angle of repose indicate life was present. End of the Archean, 2.7 billion years ago, the first eukaryotes evolved. These are organisms that have much more complex cells, such as they having nuclei in the cells, which allows much more complex organisms to form. Organisms that are eukaryotes include things like fungi, plants, and animals. And by 2.1 billion years ago in the Proterozoic, the first multicellular life forms evolved, meaning there were multiple cells, and cells had their own purpose. Life continued to evolve, and by 650 million years ago, the first sponges evolved. And during the Ediacaran period, which is the last period of the Proterozoic Eon, there was a large explosion of life. Biodiversity exploded with many life forms present on Earth. By 562 million years ago, the first jellyfish was present. Here, on this picture, is a 560 million year old Dickinsonia. However, At this time, even though life was extremely diversifying, life only contained soft tissue. Bones, shells, teeth, claws, scales had not evolved yet. Soft tissue is not easily preserved in the rock record. It can decompose, it can break up into smaller pieces, and so while we are seeing a big explosion of life, we don't have the strongest evidence of the life yet because it's broken down. Tectonically, there are also major changes to Earth as well. For example, the supercontinent Rodinia formed. Rodinia is not the first supercontinent, nor it is the last supercontinent. But the collisions that formed Rodinia lasted from 1.26 billion years ago up to about 900 million years ago. Rodinia is made up of fragments of the prior supercontinent that was rearranged. Their prior supercontinent was Rodinia, which was around about 2 billion years ago. Rodinia could be reconstructed by matching ancient mountain chains, like the Adirondacks, and using paleomagnetic evidence, pointing to which way would be magnetic north at this time frame. Rodinia began splitting up around 750 million years ago and finished rifting apart by about 633 million years ago. One fragment that rifted off was Laurentia, and Laurentia eventually became North America following the collision and breakup of Pangaea. So Laurentia can be described as Proto-North America.